Hey everyone, lovely question here. We want to find out what fraction of the area of this large white square is covered by the area of the sum of these squares that are highlighted blue. So the first thing that we can do is we can label the sides A, B, and C like this. Having a look at this diagonal line, so it goes through this vertex over here. That means that what we have is a isosceles triangle because this angle and this angle are 45 degrees. That means that this side here is A, and if I draw a horizontal line here, that will be A as well, and the same would be true for B over here. Okay, next thing that we can do is we can construct this green square, and having a look at this right triangle, it is actually congruent to these other three right triangles. If you want to see a proof of why this is true, have a look at the video shared at the end of this one. So these triangles are congruent. That means that this side, and this side are the same, A. This side here is B because it corresponds to this one. So that means this one and this one are B as well. So the last thing that we can do then is we can label this side A. These two sides would both be B, and this hypotenuse here would also be C. Okay, next thing is if I look at this length, it is equal to this one. So we can say that A plus B, or 2A plus B, is equal to 3B plus A. We can subtract B and subtract A from both sides, and this gives us 2B equals A. And let's just put a box around that one. Next, we can find the area of this large white square in terms of B. So we would say that this side square would be the area. So A plus B, or 2A plus B squared. Remember, we know what A is in terms of B, so we can substitute that into the expression as well. So it would be 2 times 2b plus b squared. 2 times 2 is 4. 4b plus b is 5b. So 5b all squared is 25b squared. And this is the area for the square. Okay, next we are going to have a look at this green right triangle. So what we want to do is we want to find out the length of C in terms of A and B. And we can do that using Pythagoras, where we would say that C squared is equal to A squared plus B squared. So now we know what C squared is. Put a box around that. And now we can find out what the area of the sum of these three blue squares is. So it's going to be A squared plus B squared plus C squared. And remember, we know what C squared is. So what we can do is we can take C squared here and substitute A squared plus B squared into this expression. So we would have A squared plus B squared plus A squared plus B squared. Well, that equals 2 times A squared plus B squared. And now what we can do is we can take the value for A, remember what that is, it's 2b, and substitute it into this expression over here. So we get 2 times 2b squared plus b squared. 2b squared would be 4b squared. 4b squared plus b squared is 5b squared times 2, 10b squared. So now what we have here is the area of the three blue squares in terms of b. So it's 10b squared. We have the area of the large white square in terms of b, 25b squared. And now what we can do is we can divide the area of the blue squares divided by the area of the white square. So it's 10b squared over 25b squared. 10 over 25, well, that's going to be a highest common factor of 5. So it would be 2 over 5. B squared divided by b squared cancels out. So 2/5 of the area of the large white square are covered by the sum of the areas of the blue squares. And there we go. That is a lovely question. As always, if you have an alternative solution, be sure to drop that in the comments below. Thanks again for watching. If you haven't already, perhaps consider subscribing to the channel. Thanks a lot.